Is blindness a barrier? No.
Is deafness a barrier? No.
Are mobility, learning, cognitive disabilities, speech impairments and others, or even a combination of them, barriers? No way. Lack of accessibility is.
Welcome to Web Accessibility for All.
Follow the blind. This journey starts now.
Hello, my friend. Welcome back to Web Accessibility for All. I am Ariel, Web Accessibility Specialist, Software Engineer, and a blind guy. Today's episode is about a technology that isn't new, and yet still makes a lot of teams uncomfortable. It's something that promises reuse, consistency, and framework-agnostic design. We are talking about web components. This is not about if web components are good or bad. Instead, we are going to evaluate how well they perform in terms of accessibility. Let me start with something that I still see during audits. Everything looks fine at first. The component has a role. It has labels. It passes automated checks. And yet, when you actually use it with a screen reader or a keyboard, something feels off. Focus jams unexpectedly. Announcements sound wrong. Interactions feel slightly disconnected. Not broken, just uncanny. That feeling didn't come from nowhere. Early web components broke accessibility in very real ways. Shadow DOM isolated content. Events didn't behave consistently. Assistive technologies couldn't reliably access internal structure. Teams got burned. And when teams got burned, they remember. That history still shapes how people feel about web components today.
What are web components? Basics, history, and why teams remain cautious.
Before we go any further, let's level set. Web components are not a framework. They are a set of browser's standards, custom elements, Shadow DOM, HTML templates, and slots. They let you define new HTML elements that work across frameworks or without one at all. That sounds appealing, especially for design systems. But unlike JavaScript frameworks, web components sit below your application layer. They live closer to the browser itself. And that proximity is exactly where accessibility becomes complicated. Jeremy Keith has been warning about this kind of thinking for years. In his book, Resilient Web Design, he puts it very plainly.
The web is not a software platform, the web is a content platform.
Web components vs. accessibility, what they promise and what users actually need.
Web components promise encapsulation.
Accessibility depends on exposure.
Web components promise abstraction.
Accessibility depends on predictable behavior.
When you create a custom element, the browser does not automatically give you interaction. It gives you hooks, not behavior. Semantic alone is not enough. This is where many teams get stuck. They expose something that looks accessible, but behaves differently than users expect. And accessibility is as much about expectations as it is about structure.
When web components improve accessibility in real-world applications.
This is where nuance matters. Web components can help accessibility when they wrap native HTML instead of replacing it, when they preserve browser behavior instead of re-implementing it, when they centralize fixes instead of duplicating mistakes. In large organizations, this can be powerful. One accessible component, reused consistently, is much better than dozens of inconsistent implementations. But these only work when teams understand what they are preserving.
How web components still break accessibility in production interfaces.
Most accessibility failures with web components don't come from malice, they come from overconfidence. This happens when teams rebuild behaviors they didn't fully understand to begin with, and every layer of abstraction makes those failures harder to detect.
2 ways to build web components.
I want to show you a pattern I still see in production. This is the version teams usually write.
1. Creating the custom element.
First, we define a custom element and attach a shadow DOM. This is a standard web component boilerplate. Nothing controversial here.
Class toggle switch extends HTML element left brace. Constructor left paren, right paren, left brace. Super left paren, right paren, semi. This dot attached shadow left paren, left brace mode colon, quote open quote right brace right paren, semi.
2. Adding semantics manually.
Next, we create what looks like an interactive control. Notice that this is not a native element. We're already stepping away from the platform.
Const button equals document dot create element left paren, quote div quote right paren, semi. Button dot set attribute left paren, quote role quote switch quote right paren, semi. Button dot set attribute left paren, quote top index quote 0 quote right paren, semi. Button dot set attribute left paren, quote aria dash checked quote false quote right paren, semi.
3. Re-implementing keyboard behavior.
Now comes the part that feels responsible. Adding keyboard support by hand.
Button dot add event listener left paren, quote key down quote, left paren, event right paren, equals greater left brace. If left paren, event dot key equals quote bar event dot key equals quote enter quote right paren, left brace. Event dot prevent default left paren, right paren, semi. This dot toggle left paren, right paren, semi. Right brace right paren, semi.
This usually works in a demo. It often passes automated tests, and it's exactly where long-term problems begin.
4. Handling pointer interaction.
Then we wire up mouse interaction manually as well.
Button dot add event listener left paren, quote click quote, left paren, right paren, equals greater this dot toggle left paren, right paren, semi. This dot shadow root dot append child left paren, button right paren, semi.
5. Toggling state.
Finally, we update state ourselves.
Toggle left paren, right paren, left brace. Const current equals this dot get attribute left paren, quote aria dash checked quote right paren, equals quote true quote semi. This dot set attribute left paren, quote aria dash checked quote, string left paren, bang dot current right paren, semi. Right brace.
On paper, this looks accessible, but what we've really done is recreate a small part of the browser without recreating all of its edge cases. Now, let me show you the version that sounds less impressive and works much better.
6. Native first version.
This time, we start by not fighting the platform.
Class accessible toggle extends HTML element left brace. Constructor left paren, right paren, left brace. Super left paren, right paren, semi. This dot attached shadow left paren, left brace mode colon, quote open quote, delegates focus colon, true right brace right paren, semi.
7. Letting the browser do the work.
Instead of recreating interaction, we wrap a native element, a button, and step aside.
Const button equals document dot create element left paren, quote button quote right paren, semi. Button dot type equals quote button quote semi. Const slot equals document dot create element left paren, quote slot quote right paren, semi. Button dot append child left paren, slot right paren, semi. This dot shadow root dot append child left paren, button right paren, semi.
Notice what's missing. No roles, no keyboard listeners, no event forwarding. It's not a lack of effort, it's a calculated move. And this is the real accessibility trade-off with web components.
Web components today. Accessibility improvements.
Now let's look how the platform has evolved. We finally have two massive wins that solve the biggest complaints.
Declarative shadow DOM.
For years, web components were invisible until JavaScript loaded. If you were in a slow connection, you saw nothing. Today, with declarative shadow DOM, the server sends the accessibility tree in the HTML, so the screen reader sees the content immediately, even before the code runs. This is a huge win for robustness.
Reference target.
The other nightmare was labeling. You couldn't easily link an external label to an internal input because of the shadow DOM wall. With the reference target API, we can finally punch a hole in that wall.
Should you use web components?
I have a simple rule of thumb. If you are building a component library, web components are powerful. They let you fix accessibility bugs in one place and propagate them to every app in your company. But if you're building a product feature, stick to native HTML. Web components are not a shortcut to accessibility. They are a responsibility transfer. You're taking the responsibility away from the browser and putting it on your shoulders. If your team has the expertise to carry that weight, go for it. But if you're just guessing, you're building obstacles, not interfaces.
Web components, accessibility, and long-term responsibility.
I want to bring this back to something simple. Web components are a decision to move away from browser defaults, a decision to own interaction patterns, a decision to maintain accessibility over time. Web components can absolutely be part of an accessible system, but only when teams understand what they are preserving, what they are replacing, and what they are committing to support long term. So, before adapting web components, ask a different question.
Are we prepared to keep it accessible?
Because native HTML gives you accessibility by default. Web components require accessibility by design. And design is not a one-time choice. It's an ongoing responsibility. This is web accessibility for all. Accessibility is not about trends, frameworks, or abstractions. It's about people and the experiences we choose to support on the web. See you in the next one. Goodbye.
Thanks for joining us today. Subscribe for a new challenge next week. And don't be shy. Leave us a review or ask your accessibility questions online. See you next week for another episode of Web Accessibility for All.